We are going to discuss about the absorption coefficient of a given material. So what are the materials? Once you have to see, these are the lead sheet, lead material, lead sheet is there. So we have to send the radioactive sources through this end. Another end the radiation will come, so that how much power it is absorbed, that power we need to calculate. Absorption coefficient we need to calculate. How many sources are there? Not only lead sources. Here in our laboratory, copper sheet also is there. Not only copper sheet, lead, copper, as well as aluminum also you are able to take. To measure the absorption coefficient or mass coefficient of a material, given material, whether it may be aluminum, lead, copper. So we need the operators. First one is GM counting system. The second one is the window, GM detector window. The third one is sources. This is the strontium source, and this one is a cesium source is there. Already I told you, cesium will give the two radiations. One is beta radiation, another one is the gamma radiation. And strontium will give only one radiation. That radiation is gamma radiation only, beta radiation only, that will give. Clear? So these are the nuclear sources. We have to keep all these operators in one side. Now we will go for the formula. So what is the formula? I is equal to I naught into e to the power of mu x. This is the formula, where I naught is the virginal intensity of the beam without observer. I is the intensity through the observer thickness x. Mu is the linear absorption coefficient of the medium. So from this formula, whenever half of the radiations you have to consider, that mu is equal to 0.693 by x of, this is the formula. This is a linear absorption coefficient. What is the mass absorption coefficient? Mass absorption coefficient is equal to linear absorption coefficient by density. Right? What are the unit? Linear absorption coefficient unit is per centimeter. Mass absorption coefficient unit is centimeter square per gram. So what are the densities of the material? Different materials have different densities are there, mass by volume. Aluminum sheet density is equal to 2.7 gram per centimeter cube. Lead sheet density is equal to 11.34 gram per centimeter cube. Copper sheet density is equal to 8.34 gram per centimeter cube. These are the densities of the different materials. What we have to do? First we need to take the observations. Previously we discussed, so previously what we have to discuss, we are discussing about the operating voltage of, for different sources we calculated the operating voltage. Suppose if you have to take, this is a strontium source you may take. Strontium operating voltage 470 volts we calculated previously. Now what we have to do, this strontium you have to keep for so for you have to keep, it is a 2 centimeter distance you have to keep. So that strontium you able to keep here. Now I am keeping the source. So what background count you have to calculate in the program? You go for the program. After going the program, what you have to do? You first fix that operating voltage. How much voltage is there? Operating voltage 470. 470 you have to fix. 470 you have to fix. This is the operating voltage 470. 470 you have to keep, right? 470. This is the 470 is the operating voltage. Clear? So once 470 you set it, now you store that 470 in that mission. Later, for how many times you have to calculate? For how many times you have to calculate? So again you go to the program. After going to the program, what you have to do is, so you set the preset time, wherever the preset time come, for that you have to go preset time is there. How much it is there? 30 seconds. Already 30 seconds is set. So that's why once again you have to store it. Now you start that. So you start for 470 voltage. So now for 30 seconds, how many counts are coming? So those counts you have to do that one. Clear? With the source. First I am keeping this. What you have to keep? First you able to take first copper sheet. I am taking copper sheet. This is the copper sheet holder. So you have to keep the copper sheet holder in 2 centimeters length. You have to keep it. Now the source you have to keep below these 2 centimeters. You have to keep the source, right? So without copper sheet, I am sending that first one. Now I am using the copper sheet for various thickness copper sheets you have to keep. Again you start it. So what will happen? Already I told you. So according to the classically, any particle cannot penetrate through this barrier, right? But in quantum mechanically, the nuclear radiation so can incident one side and penetrate through other side. So how many radiations are penetrating? Those radiations are the detector is acquiring. So those acquiring detector radiations are obtained by this detector. How much you are coming? 293 you are coming. Once again you have to start. So what will happen? So the radiations are increasing. The count is increasing. Clear? Now you have to take. So for 30 seconds you have to keep that one. First one sheet you have to keep. The second sheet you have to keep. And third sheet you have to keep. And so two thicknesses you have to keep. And then you calculated the values. So that values you make the plot. What is that plot? You have to make it. How much counts per 30 seconds? You have to take it on y-axis. In x-axis you able to take it as a thickness. You have to take the x-axis. The curve will come like this. So what is the maximum? That maximum you have to take it as a I naught. So I naught by 2 you have to write it is. Here I naught by 2 it will come. Now you extrapolate it. After extrapolating, wherever the intercept of the x-axis, that intercept you have to take it as a x of. This x of you have to substitute. Where you have to substitute? 0.693 x of you have to substitute. You able to get it as a linear absorption coefficient of copper. So otherwise if you have to take the lead sheet, you able to get it as a linear absorption coefficient of the lead. Now what is our ultimate goal? We need to calculate the mass absorption coefficient. How we have to calculate the mass absorption coefficient? Linear absorption coefficient of density of corresponding to that material. Whether it may be lead sheet, lead density you have to use. Whether it may be copper sheet, copper density you have to use. You will get the answer. What that answer you have to get? Approximately your copper sheet will give. So linear absorption coefficient 161 per centimeter. Lead absorption coefficient 11.55 per centimeter you are going to get. So your mass absorption coefficient you may get the 18.04 for copper, and lead is 5.55 centimeter square per gram. So this is the mass absorption coefficient. Clear? So like this we need to calculate the absorption coefficient, linear absorption coefficient, mass absorption coefficient of a different given material by using the GM counting system. It is very important. So please share, subscribe and like our YouTube channel. Thank you.